Hi Calculus student, this video is for chapter 5.6 part 1, integral involving exponential and log functions. So it's actually continuation with U substitution where the outside function is a e to the x, or the outside function is 1 over x or 1 over something. So if we have e to the, like whenever in the past, if we have g of x, if this is a y, remember when you do derivative, it will be y prime equal to the same e of g of x, but then because this is like the inside, and then you do g prime, right? So the same idea would be for integral. So if you do integral and I see something here, and I would notice if I see some g prime of x outside, if I do that, then the integral would be the e(g) of x. So that's the idea. So, and then the second part about ln would be, in the past, we would say, if I have y equal to ln x, and I do y prime is equal to 1 over x, right? So if I see 1 of something, if I look at the denominator and there's no it's something that is an expression, maybe I'll use that as u, and then I would the derivative would become um, um, lnu. Okay, so this is the idea. So let's do a few examples. So whenever you do an integral and you see e of something, this something would be a target for u substitution. You would say, let me do u equal to 3 minus x squared, see if it works. And you will notice that there's something outside, like x dx, that waiting to be replaced. So you do the differential, du will be negative 2x dx. Your x dx is right over there, so why don't you divide both sides by negative 2? So you have x dx. And that's exactly what you replace. So this integral now will become e of, you're not replacing the whole you're replacing this exponent, e of u, and then x dx become 1/2 du. Oh, actually it's negative 1/2. So you move the negative 1/2 outside. So it'll be e of u du. And this is just e of u. So become negative e of u. U is 3 minus x squared over 2 plus c. So you change it back to x when you're done with your integral, because this is an indefinite integral. So this case, we notice that this is the exponent. Again, it's x to the 4th. If I do a derivative, I should have x cubed. So this is set up so you can do u substitution. So 0.1 x to the 4 du would be 0.4 x to the 3 dx. So I have x to the 3 dx. So this is 2 over 5, right? So I'd say 5 over 2 of du would equal to, because it's 2 over 5 times 5 over 2, that would be x cubed dx. So that's what I use to replace it. So this, after you do substitution, it becomes 5 over 2 times 2, or outside, and then e of u du, because x cubed dx is 5 over 2 over here. So it'll be 5 e of u plus c. But e of u is 0.1 x to the 4th plus c. So that's for e. And then let's do the ln part now. So you see how this is just a integral with 3x plus 4 is not in the top. It is just 3x plus 4. So what you can think of is, let's just replace this by u, px plus 4. And then I have to replace dx, so I have to say du equal to 3 dx. But I only need dx, so it would be, you would say dx is 1/3 du. The 1/3 can move outside. So this would become 1/3. Dx become 1/3 du, so have du, and then the bottom is u. Or you can write it as 1 over u du. Okay, whenever you have 1 over u du, we know that it is ln of that u, and then you will put it back 3x plus 4 plus c. The fourth one is 3x plus 6, x plus x squared. So seems like a ratio of two functions. But you would look at whenever there's something in the denominator, but it's not a square root, it's not a cube or something, you cannot tackle it by power rule. Then you can think of being maybe converted to 1 over u. So just let the whole denominator by this. Then your du would be 1 plus 2x dx. It's like two terms. But you say, I don't have 1 plus 2x, I have 3x plus 6. Well, if you do multiply both sides by 3, you would have 3 plus 6x dx. So 3 plus 6x dx can be replaced by, so you would say like this. This would become 3 du in the top, and the bottom is du. Right? It would be 3, 1 over u du. This is u. So it'll be 3 ln u, absolute u, plus c. But u was x plus x squared, so you would say 3 ln x plus x squared plus c. Example 5 is a kind of a difficult one, so maybe we'll talk about those in class. Basically the u substitution is you actually, whenever you see ln in a integral, actually that is your substitution. And then your du is actually 1 over x dx, which we have, right? Which we have. And the 1/3 you can move it outside, so you can still do a substitution. We have some more here. We have 2 more, and then maybe let's do 2 more, and then we'll do the other one. So this is 0.3, 2 to the x dx. So we know the rule of if I just a b to the x, what is it? A to the x. We have a rule of a to the x dx will equal to a to the x over ln a plus c, right? So I have 2 to the x. This 0.3 can move outside, so we'll say 0.3. 2 to the x over ln 2. That's the answer, plus c. If you want it nicer, 0.3 is 3 over 10. So you can say, yeah, you can say 3 and then 10 ln 2 times 2 to the x plus c. So to make it nicer. 7 is tangent x. Now tangent x is, there's no reverse antiderivative for tangent x. So how do I do it? So I would write tangent x as sine x over cosine x, use identities. And then you see that there's a denominator of cosine x, so that would be my target for u substitution. U equal to cosine x, but then du would be negative sine x dx. Now I have a sine x dx, so the negative du will be sine x dx. So I can replace everything now. So this whole thing would be replace it as what? The bottom is u, the top is du, negative. So that means negative ln absolute of u, or negative ln absolute of cosine x. Now a negative means to the power -1, so we can also move it as power of -1 over cosine x. That means absolute of secant x plus c. I have to do plus c here also. I think I should do plus c here also. And then number 8 would be very strange. You have e and then you have cosine. So we say whenever we see e of something, that would be our u our target, right? U equal to cosine x, because it's in the exponent of y. Du would be negative sine x, dx is negative. Oh, but this is also a definite integral definite integral that we need to do. So we have to replace the whole thing. So we get that sine x dx. So we say negative du is sine x dx. We also need to replace the pi over 2. So we would say u of sine over 2, u of pi over 2 is equal to cosine pi over 2 equal to 0. U of 0, that is cosine 0, equal to 1. So the whole thing now change it into 1, 0. It's kind of switch. The lower number is bigger. And then my top will become u, my bottom is du. My top is du, the bottom. No, this is not. It's e to the u. Sin x dx is du. Oh, a negative du. So it become negative e of u from 1 to 0. So we can change it to positive. Well, yeah, maybe we should do that. 0 to 1, positive, and e of u. That means, so just cross this out. That means e of 1 minus e of 0. So that's e minus 1. So, and then we'll do definite integral. There's a definite integral here already. Oh well, we started already. So we'll do more of these in the next videos.